Hello. Okay, I will take just a few minutes. Dear participants, thank you very much for enrolling yourself for this training program. In fact, TCS has created a separate group for all the placement and training officers, and they generally keep conducting meetings for the training and placement officers. So, in one of the meeting, they mentioned the possible or the areas under which the company will be checking the students. And they've listed various topics. So I've requested our faculty members to do some awareness program or educative program for all the students. So in this connection, Dr. Harish Kumar and others, Dr. Shankar Gowda, Dr. Vijay Kumar and Dr. Gunavati, Tejaswini,
Netravati, sir.
Tejaswini and Netravati. These people have come forward to take sessions and give some input on various topics that TCS will be mainly looking into. And the latest information as per the TCS communique is they're going to recruit about 40,000 freshers shortly. So keeping this in mind and also looking at the registration rate of BIT students in the TCS online recruitment process, the numbers are very less. When TCS visiting BIT campus physically, a lot of students used to opt for TCS, and we used to have more students getting selected to TCS. But once they started this online recruitment process, the number of students who are opting for TCS are very less. So I don't know the reason whether the students are aware of it or the competency levels are little high, or since it is an online all India recruitment process, a lot many campus students will be participating. So the number of overall students participating in the process is huge, and the number of selectees from each campus will automatically reduce. But however, since TCS is one of the reputed companies and a very strong company to work for and to build our career, I strongly recommend all of you to enroll for TCS recruitment process and prepare yourselves as per the requirements of the TCS. You can also do some more research on visiting TCS website, the kind of projects they're doing, and get yourself equipped in the areas TCS is working and the areas in which the TCS is going to recruit. So, with this opening remarks, I wish all the participants a nice learning experience. Interacting with you. So understand the basic concepts and basic principles of all these areas, operating systems, SQL, and other things they have mentioned, the core Java and other areas.
Yep.
That is nowadays the programming and the programming knowledge is very essential both for core engineering as well as the IT related branches. So I wish all of you all the best, and please make use of this program. And on behalf of BIT, I would like to extend my thanks to all the resource persons who have come on their own to assist the student community during this COVID-19 pandemic crisis. And once again, thanks to all the resource persons. So I wish all of you a good time and good learning. Thank you very much, Dr. Harish Kumar. Please go ahead.
Thank you, sir. Thank you.
And Vijay Kumar is also involved in this. Vijay Kumar, Harish Kumar, Shankar Gowda, Tejaswini, and Netravati. All of them are from Computer Science Department, and I wish you all the best. Thank you very much, Harish, and please
Thank
go
you, sir.
ahead and
Thank you.
have an interactive session.
Okay, sir. Okay. Thank you, sir.
Thank you.
So, good morning, all the students. It's pleasure for me to connect with you all virtually and conduct a training session on my subject, that is operating systems. When principals are told TCS is asking for the expertise in these subjects from the students, operating system, database SQL, problem solving, core Java, and J2EE. Dr. Shankar Gowda, Vijay Kumar, me, myself, Tejashwini, and Netravati, madam, agreed, and we are here to train you people with respect to these courses, what the TCS is currently looking for. We, in fact, we also checked for getting the course handout, the TCS specific course handout, but we were not able to get it from the TCS. What we have done is we have organized our content delivery, which is very much required. We have identified such topics and we have organized our own content delivery. So now today I'll be delivering the session on the operating systems. So I'll be just Yeah, I'll be taking three sessions for you people. Session one is today. Today I'll be covering with the operating system basics, process concepts, process scheduling. So I'm just planning to cover these three things for the today's session. So these three. And then session two, my next session will be on 21st/7/2020. So there I'll be concentrating on process scheduling. Of course, I'll be starting with process scheduling today in today's sessions itself. But it's not possible to complete the complete process scheduling thing in the today's session. I'll be continuing the same in the next session also, that is 21st process scheduling, and then I'll be discussing with the process synchronization. And then in the session three, the last session of mine, I'll be discussing with the deadlocks, memory management, and finally I'll be giving a small demo on the CPU OS simulator, which you people can use and simulate most of the things which I'll be explaining in these 3 day sessions. You can simulate the process scheduling, you can simulate the process synchronization, deadlocks, even the memory management. All these things can be simulated using this beautiful CPU OS simulator. Before the start of the session 3, I'll also be sharing the link, download link for the CPU OS simulator. And I request all of you to download and install this. And when I'm demonstrating the same, it will be very useful for you to practice at your end. So this is what I have planned. So starting with the operating system basics. The first thing is operating system, and the students are from both the streams, IT stream as well as the non-IT streams. The students from the IT stream, they have already studied operating systems and they know what is operating system. So this entire 3 day session will be something like the brush up activity for all the IT students and non-IT students, those who don't have the knowledge about the operating system. They can understand the concepts and they can get thorough with the concepts and they can themselves get prepared how to face the TCS, because TCS is looking for these 4 main courses. One is the operating system, database SQL, problem solving skills, and one expertise in one programming language. And we have chosen Java as the programming language. We have core Java also and J2EE also. So let me come to my topic, operating systems. When we say operating system, so operating system is an intermediary between the user and the computer hardware. So it acts as intermediary between user and computer hardware. That means whenever user wants to perform some operation, so for some computation, so you cannot access the bare hardware resources. So if the user wants to perform some computation using the hardware resources, it must be through the operating system. Now, operating system provides all the necessary facilities for the user to run his applications and access the computer hardware resources. And uh, using this, the applications will execute and provide the required computation to the users. And what are the main goals of the operating system? Uh, One thing is to execute the user programs and make solving the user problems easier. That means without the operating system, you don't have the resources allocated to the user programs what we write or the application programs what we write. So operating system is responsible for fairly allocating all the computer resources which are available to the application programs for running efficiently. So we have many applications or the many processes or multiple processes running on the system simultaneously. But what we have is the limited resources. Now, operating system is responsible for efficiently allocating these limited resources to the n number of processes that are running on the computer system. So that is what one major goal of the operating system, efficiently allocating the limited resources to all the processes which are running on the system. In other words, I can say fairly allocating the limited computer resources among all the processes which are running in the system. And then making the computer system convenient to use. So without the operating system, so it's not possible for you to use the operating system, or else I can say operating system is the one which makes the computer systems user friendly for the user to use. And then, as already mentioned, it efficiently allocates the computer hardware resources to the n number of processes that are running. So this is what the complete idea of the operating system. Operating system is a software which stands as an intermediary between the computer user and the computer hardware. So if the user wants to perform any of the computation through his application software, so all the application software will be communicating with the operating system, and the operating system in turn communicates with the bare hardware resources, and you have the computation done. And again, the question is how the application software will communicate with the operating system. There are something called as system calls. Now, and system calls are something like the doors to gain access into the operating system. Now, you've got to make your application program call the system calls in order to obtain the required service from the operating system. Not like there is only one system call through which an application program can get the service from the operating system. There are many system calls, and whenever an application program is looking for a service from the operating system, it should know through what system call it can access that service. So we have multiple doors to enter into the operating system. So only thing is the application program should find out with what door it should get into the operating system in order to get the required service from the OS. So this is what the complete definition of the operating system. And when we look into the computer system structure, we have four major components here. One is the hardware, operating system, application program, and users. Now, hardware, computer hardware, there are three precious resources of the computer system. One is the CPU, memory, and IO devices. So these three resources are considered as the most precious resources of the computer system. And whenever you any application program which you write, it should not make wasteful usage of these resources. This is one component of the computer, and then the operating system. So as usual, this is required in order to control and coordinate the use of hardware among the various application programs. And then application program, these are the one which are written by the user in order to get their computing problems solved. So examples of word processors which we use, the compilers, web browsers, databases, video games. So these are all few what application programs that will be interacting with the operating system in order to perform the computation. So, and finally, the users. Okay, all these four components make the computer system structure. So, the pictorial representation of the same, we have the users, and then the lowest level we have the computer hardware, and then on top of it the operating system, and then the application programs, and then the user the application programs, and then finally the users. Now users will make a request through his application program to the operating system. So these two, they'll communicate through the system calls, or you can also call them as APIs. So they communicate through the system calls, and the operating system receives the request from the application program through the APIs or the system calls, and then facilitates how this computer hardware resources should be used by the application programs in order to perform the execution of the application programs. So other definitions of the operating system. So you can view the operating system as a resource allocator because it's responsible for allocating the resources to the all the processes which are running on the system fairly allocating, and then you can also consider it as a control program because it controls the execution of various programs. Even if some programs tries to perform an erroneous operation, so operating system will try to prevent that. Say for example, any program which is trying to perform divide by zero operation, so operating system will intervene and it will try to terminate the execution of such processes, because divide by zero is not at all possible. Divide by zero leads to an infinite results, and we don't have sufficient resource to accommodate the infinite result. So so when I say operating system, you can define it as a resource allocator or a control program, the program which controls and coordinates the execution of various other programs. So there is no universally accepted definition. So you can go for defining the operating system in your own term. Okay. So now, and within the operating system, the core part of the operating system is called as the kernel. So where the most basic services are residing. So, and then the computer startup. So that is a program called as bootstrap program or the bootloader code, which is permanently residing inside the ROM, read-only memory. So the moment you switch on the computer system, this bootstrap program is the one which will be running first. And what is the responsibility of this program, bootstrap program? It's responsible for loading the entire operating system onto the RAM. So bootstrap is permanently residing inside the ROM, read-only memory. The moment you switch on the computer system, this is the first program that is going to run. And what it is responsible for? It is responsible for loading the operating system onto the memory. So once the operating system is successfully loaded into the memory, so what bootstrap program will do is it will hand over the control to the operating system, and then it stops its execution. So next, what we have is the process concepts. So till now, I told very basics of the operating system, and this is important now. So the concepts of process. So because process are the building blocks of any operating system. So we understand the concepts of the process. So what are the different operations that you can perform on the process? What are cooperating processes? Inter-process communication. How do we make one process to communicate with the other process? So the process inter-process communication or making the process which are residing on two different systems to communicate. For that purpose, in order to make the processes which are residing on two different systems to communicate, you have to use the socket programming and all. And then finally, we understand the process scheduling. Yeah. So process concept. So early days, so only one program used to execute. But today's computer, even if you have only one CPU, single CPU, it's capable of executing multiple processes in a concurrent manner. So you don't have all the programs getting executed simultaneously if there is only one CPU. Now what it does is, so the concurrent execution or execution of the programs in an interleaved fashion is possible. That is executing some part of the first program and then making the CPU switch from that program to the another program, executing some part of the other program and again switching back to the first program. So this is called as executing the processes in a concurrent manner or in an interleaved fashion. And this switching from one process to the another process happens so rapidly that we get a feeling the processes or the programs are getting executed simultaneously. So now, what is a process? Process in general is a program which is loaded into the main memory and which is under execution. We call it as the process, and and the process, it includes all these things. Whenever I say process which is loaded into the main memory, it has an address space allocated to it. So the address space of the process constitute these four major things. One is the code section, another one is the program counter, stack, and then the data section. Of course, you have also have the heap section. So the code section is the one which contains the data. So this is called the code section. And then the program counter is the register which holds the address of the next instruction to be executed by the CPU. Or in other words, I can say the program counter acts as the guide for the CPU. If there is no program counter, the CPU doesn't know how to perform the execution or what to execute next. So the program counter always guides the CPU and tells what the CPU should do next. So this program counter holds the address of the instruction that should be executed next. And then we have the stack. Every process will have its own stack, and the stack is used in order to store the return addresses. Whenever there is a function call made within the process, so the return address will be saved onto the stack, and then we have the data section, which holds all the data related to that particular process. Now, all these four major section, including the heap section, and heap is used for dynamic memory allocation. Okay, so all this section, they constitute the address space of a process. So now time to understand the process states. Whenever a process is created till it dies, so it will be changing from one state to the another state. So first thing is the new state. Whenever the process is created for the first time, we say it is in the new state. Once the CPU is allocated to the process for execution, we say it is in the running state. And that process which is executing currently wants to perform some event, say for example, input output operation. Say process wants to perform an IO operation, either reading something from the keyboard or displaying something on the standard output or reading something even from the file. All these things, we don't have the main CPU involved in it. So all these things will be taken care by the special processors called as IO processors, input output processors. So at that time, we say the process is in the waiting state. It is waiting for the completion of input output operation, and meantime the main CPU can be used for running the other process. So next we have the ready. So once the process is created for the first time, we say it is a new state. Once it is ready for execution and waiting for the allocation of the CPU, we say it is in the ready state. Once the process finishes its execution while in the running state, it is moved to the terminated state. So these be living during its lifetime. So, or during its lifetime, the process will be changing the stage from this one state to the another state. So, this is the pictorial representation of the same. So, whenever the process is created for the first time, we say it is in the new state, and then when it is ready for execution and waiting for the allocation of the CPU, it is admitted into the ready state. So here, if I say the process is in the ready state, it is ready for execution and just waiting for the allocation of the CPU. So once the CPU is allocated, so it moves to the running state. So the movement of the process from the ready queue to the running state will be done by the scheduler dispatch. So this is responsible for granting the allocation of CPU to the process which is waiting inside the ready queue. So now once the CPU is allocated, we have it in the running state, and the process is having the CPU and it is performing the execution. Now when it is executing, if it executes completely, so then it is moved to the terminated state. In case while it is executing, so if there is an interrupt or if it wants to perform an input output operation, so then it is moved to the waiting state. So if there is an interrupt, in the sense, if some other highest priority process comes and uh, if it needs the immediate execution, so then the process which is currently executing is interrupted and it is moved to the waiting state, and the chance is given for the highest priority process to execute. And the process will be waiting here. And when the interrupt is complete or the input output operation is complete, the process is again added back to the tail end of the ready queue. And again, the process keeps waiting here until the CPU is allocated for it to resume its execution. So this is the complete diagram, process state diagram. And this is very much important, the process control block. This is a data structure. So every process has its own PCB, process control block. And this is very much useful for saving the state information of the process. Whenever the process switches from CPU switches from one process to the another process, so the current state of the process which was executing already should be saved. Now where it will be saved? It will be saved into its PCB. Every process has its own process control block, and whenever the CPU switches from one process to the another process, the current state of the process which was executing will be saved onto its PCB. And the same PCB will be used in order to resume the execution of the program next when the chance is given for the same process again. So what are the fields that will be there inside the PCB? There are many fields, but a few things to know. One is the pointer. So this helps in creating a linked list of PCBs. So if you have studied the data structure, you'll be knowing the singly linked list, and this will help in creating the singly linked list of all the process control blocks. And then the process state, this states what is the current state of the process, whether it is in the new state or it is in the running state, whether it is in the ready state, terminated, or waiting state. So next, this will be holding the ID of the process. Every process is given a unique identification number, and this will be holding the ID of the process. And then the program counter, this tells which is the next program, which is the next instruction to execute. And these are the CPU registers. When the CPU switches from the process, what it is executing currently, to the next process, all its CPU registers will be saved onto the PCB, and this will help in resuming the execution of the process again after some time. And then memory limits and list of all the open files, what are all the files the process is open, it will be maintaining the list of all the files, so that when the process again resumes its execution, so all the list of files what it has opened earlier will be made available to the process. So process control block is a data structure which is associated with every process, and this will be used in order to save the context information of the process when it is when the CPU is switching from one process to the another process. So this is the same thing. I've already explained you the process state, program counter, CPU register, scheduling information, memory management, accounting information also. That means what is the amount of CPU time the process has consumed till now. So all these things are what the amount of memory the process has consumed till now. All these things will be maintained in the field which is reserved inside the PCB, that is accounting information. Yes, please mute. Hello? Yeah. Yes, please mute. Hello? Mute, please. Yeah. So now this diagram, it depicts how the CPU switches from one process to the another process. So a CPU can execute only one program at a time, one process at a time. So this is process P0 executing, and this is the process P1. I'm saying the process P0, I'm assuming among these two, the process P0 is executing. It has a CPU and it is executing. So it's executing, and when process P0 is executing, you can just observe here the P1 is idle because only one can execute at a time. So this at this point of time, so there is an interrupt or a system call. So then the execution of P0 is suspended. Execution of process P0 is suspended. When it is suspended, so we can't let the CPU sit idle. So we got to keep the CPU busy always. So in order to do more work in less time or to increase the throughput of the computer system, the CPU should be kept busy all the time. Say when P0 suspends its execution at this point of time, what will happen? So the current state of this process P0, all its execution status will be saved onto its PCB, that is PCB0. So PCB0 is the data structure which is associated with the process 0, and all its current state information, execution state information is saved onto the PCB0. And then, so CPU will simply switch from this process P0 to process P1, and to resume the process P1, so the CPU should reload the state information of the process P1 from its PCB, that is PCB1. So from PCB1, the status information is reloaded to the CPU registers, and we have the process 1 executing. And now here again, say there is an interrupt, or the process P1 wants to perform some input-output operation, some input-output event. So then what will happen? So again, so the current state of the process P1 is written, saved onto the PCB1, its own data structure. And then now the CPU will go for resuming the execution of process P0. We are assuming, so meantime, we have the process P0 completing its event, or input-output activity or interrupt is completed. So now, so process CPU will reload the status information of process P0 from its PCB, that is PCB0, to the CPU registers, and we have the process P0 resuming its execution and continuing. So this is how the CPU switches from one process to the another process. Whenever the CPU switches from one process to the another process, there is a context switch happening, that is saving the current information of the process which is executing to its PCB and reloading the status information of the next process to the CPU. So, and this context switching time is actually the overhead time, that is saving the status information of one process to the CPU and reloading the status information of another process from its PCB to the CPU will take some finite amount of time. So this is actually the overhead time. So if the context switching time is too large, then again it will reduce the throughput of the computer system. So we should work on how to reduce the context switching time. So next is process scheduling queues. So we have the set of all the processes in the system, the set of all the processes which are there in the system. We say it is a job queue. So it is a large pool of processes, and we say it is the job queue. And then the ready queue, the set of all the processes which are residing in the memory. So we have all the processes, the programs in the system, and then the ready queue, all the processes which are loaded into the main memory, we call them as ready queue. And ready queue has two things. One is head end and another one is the tail end. Yes. Please mute. Yes, I request everyone to mute, please. Okay, ready queue has two ends. One is head end and the tail end. So the header node has two pointers. One is the head and another is the tail. Head always points to the first PCB and the tail always points to the last PCB. So, and then there is something called as device queues also. Whenever the process is waiting for the allocation of the CPU, it will be there inside the ready queue. Whenever the process is waiting for the allocation of the IO devices, it will be there inside the device queues. So you'll be having only one ready queue for the entire system, but the device queues you can have n number of device queues. It depends on how many devices are available within the system. So this gives a pictorial representation of the same. This is what is the ready queue seeing. So this is the queue header with two nodes. One is the head. So this is pointing to the first PCB, and the tail always points to the last PCB. In the sense, the head is holding the address of the first PCB, and then this pointer field here, I told in PCB there is a pointer field. So this will be holding the address of the next PCB. So there is a chain of all